Good.
Stepster. I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today we're going to be looking at the anatomy of an atom. They are the building blocks of everything you see, touch, and breathe. So let's get into it.
hmm So let's start with talking about an atom. So what is an atom? It is the basic unit of matter. And obviously, if you want to look at atoms, that's not possible with just your eyes because they're really, really small. So they're too small to see with regular microscopes. Isn't that crazy? Like imagine you're using a microscope and you still can't see it. So They need they need special microscopes that can zoom in enough for to be able to see them. And then obviously an atom makes up everything around us, including us.
So let's talk about the parts of an atom. So these are known as the subatomic particles. These are what an atom is made up of. So it has the protons. These are positively charged and they're found in the nucleus of the atom. So an atom, for example, it looks like this. It has a circle, and this is what is called, let me just delete that. Let me redraw that. Okay. This is like nucleus, and that's like the where the protons and the neutrons, which have no charge or neutral charge, are found in the nucleus too. So for this example, let's just take one proton and one neutron. So the neutron has no charge. We have the protons and the neutrons in the nucleus, while we have the electrons, which are negatively charged, and they orbit the nucleus. So we have like an orbit around the nucleus, and then let's say we have one electron. Okay, it's negatively charged and it orbits the nucleus around a shell. These are usually called shells or electron clouds, which you're going to look into later in this presentation. But for now, just know that these are orbits that the electrons go through surrounding the nucleus.
hmm Okay, so now let's talk about the nucleus, which is called the heart of an atom, or you can think of it as the heart of an atom. So, like Lasia said, it contains the protons and the neutrons, which are packed tightly together. Now, if they're packed tightly together, they're going to be really dense. So, guess what? The nucleus of an atom is what holds 99.9% of the atom's mass. And you're probably like, why only 99.9? Where's the other 0.1%, right? That is basically for everything else, like the electrons that are orbiting. No, that is crazy, isn't it? Think about it. The electrons that are orbiting, no matter how many there are, they're only going to make up 0.1% of an atom's entire mass. And an atom's mass is really tiny too, so kind of cancels that out. And yes, like I said, they're tiny compared to the entire atom. So an entire atom is probably going to be a lot bigger than the nucleus itself. So for example, let's say this is our nucleus, and then the reason why an atom is bigger is because it doesn't only have one orbit, but it has multiple orbits. And this shaded region is our nucleus. So because of that, if you think about it, this is our nucleus, right? I'm going to represent that by N. And this entire thing is our entire atom. So just if you look at it, just looks wise, you can compare the size of the atom with the nucleus itself.
Now let's talk about the electrons. So these are the fast movers. Okay, here are some facts about the electrons. They move at nearly the speed of light. That means they move really fast, right? And that's really amazing, right? Because they move almost every single second. And they form energy shells or clouds, like I said before. So electrons, while they move, right, in such a like fast speed, they creates shells around the nucleus or clouds. They're called electron clouds around the nucleus. And they create mostly empty space in atoms. So, the nucleus is tightly packed with neutrons and protons, so that's not the empty space. But the electrons that orbit around the nucleus create empty space because they constantly keep moving around. And they also determine the chemical properties. And you're going to learn more about this later in this video.
Okay, so now let's talk about how small atoms really are. So let's let's start talking about an atom's diameter. So just an atom's diameter itself is 1 nanometer, and nano is a really small unit, which is about a billionth of a meter, and you know how big a meter is. Now think about a billionth of a meter. It's going to be really tiny. You're probably not going to be able to see it. And then let's compare that to our hair's width. So if you just take one strand of your hair and you look at it, you're probably like, oh, that's really thin. Now, that width itself is 10,000 times wider than an entire atom, which is crazy, isn't it? And the actual width of a hair is 100 micrometers, and micro is a bigger unit than nano. And then let's talk about what if I spread atoms out in a length of 1 inch? What would the size, how small or big will it be? So if in an entire inch, if we spread atoms around, the size would be about 25 million nanometers. And that is probably, even if you do that, you still are unlikely of being able to see it because, like I said before, nanometers are really small units.
Now, let's talk about elements and what makes atoms different. So we have the proton count, which is same as the element identity number, which is the atomic number basically. And each element has a unique number of protons. So we have 118 different elements in the periodic table, from hydrogen, which has one proton, to organoson, which has 118 protons. So as you can see that we have different types of protons and different numbers of protons, not types, but numbers of protons for each of these elements. And just remember that the proton count is equal to the element identity number, which is also known as the atomic number.
Mhm. So now let's talk about using the periodic table. So we're going to talk about how to read element information. So there are three main things, and one of them is probably not going to be seen in the actual periodic table, but we can find it out just by looking at it. So the three things you need to know when you see an element is the atomic number, which is the big number that is probably on the edge of your element. This is going to be your atomic number. And then we have neutral atoms. So always remember that the number of protons is going to equal the number of electrons. And yeah, you're probably not going to be given this in the actual element itself on the periodic table, but you can definitely calculate this. And then you're given your mass number, which is this thing right here. And another thing that isn't mentioned here, but some periodic tables do have, is the name of the element itself, which is going to be carbon in this case. So it'll look somewhat like that if the name was given. So remember, the top number is the atomic number, then there is your element name, and then there is your mass number of that element. And you will be using these later for calculations, so that's why it's necessary to know these.
And
And if you
also,
want, Go.
Also, know that C is just like the atomic symbol for that element. So for carbon, it's C, and oxygen it's going to be O. For hydrogen, it's H, and so on.
Hmm. And do not assume that every single one of them is just the first letter. Because, if I want to compare like carbon with like cobalt, and obviously they both won't have C as their symbol. Yeah, and every single one of these elements are all different, so they're all going to look different too.
Now let's talk about how you can get from atoms to molecules. So atoms actually make molecules. Atoms are the building blocks, like we talked before. They're the smallest units. And then we have bonds. So atoms share or transfer electrons with other atoms. So, for example, in here we have some molecule examples. We have H2O, CO2, C12H 22O11. This is a really big one and it's really complicated. But it just like it's as simple as these when you actually like look at them, like how atoms share or transfer electrons to combine with one another. So what I mean by this is let's take H2O for example, right? That means we have two H's, okay? So that's two H elements, so hydrogen atoms, um, there and there. And then we have nothing under O that actually means, so if I write this down like H2O, there's nothing under O, right? Which is oxygen. That means there's in an invisible one there. So that means you have one oxygen combining with these two hydrogens. So what it basically means is the one electron from hydrogen and the other electron from hydrogen, they both are being attracted to this outer shell of oxygen. So this is really complicated because it goes into like how, oxygen has so many amounts of electron shells and it has like so many amount of spare electrons which can be combined with other atoms like hydrogen in this case. But all for now, you need to know that is there's like electrons for hydrogen and the other electrons for this hydrogen, they combine with the outer shell of the oxygen um, to make a bond and to make a molecule. And in this case, it's H2O. Same for CO2. And CO2, we have one C, so just draw a C. And then you have two oxygens. So one there and then one there. So two oxygen. So all this means is oxygens are sharing or transferring their electrons with the carbon. Just remember that for now, and later on, when you go into high school, you're gonna go into more complicated stuff, like I told you before, about the transfers of electrons in the outer shell and why that occurs and so on. So chemistry is really like um deep and it has many topics into it. So for now, just learn the basics, so later on it gets easier for you to understand more complicated stuff.
Hmm. So now let's talk about atoms in our everyday life and a small recap of everything we just learned. So we know that atoms make up all matter in our universe. And then we also know that protons, neutrons, and electrons are the building blocks. We also talked about how protons have a positive charge, neutrons don't have a charge, and electrons have a negative charge. And these all make up an atom. And we also learned that neutrons and protons are tightly packed in the nucleus, while electrons are freely roaming in their own orbits around the nucleus. And then now let's think about where atoms can be used in our everyday life. So, if we can understand atoms, it can help us create medicines, materials, and technology. Because think about it, a lot of mutated things nowadays are because of combination of different atoms. And if if we truly understand how atoms work, it can not only help us make new material, but it can also help us make innovations that could possibly lead to a greater future. That's why, children, atoms is really important, and you guys hopefully look through this entire video and learn something, if not everything, because you guys can definitely go back to the video or comment on any questions, comments, concerns, or video requests. And that's all we have for you today. Thank you so much for watching our video. Have a great day. Goodbye.
Bye, Stepsters.